My name is Ross Ashdown and I'm the Product Manager for MPAES and ICP OES for Agilent Technologies.
And I'm Shane Elliott, the Director of Marketing for Atomic Spectroscopy at Agilent Technologies. Agilent have a proud history in ICP OES technology spanning over 25 years. Valuable customer feedback have driven the team here to continue to innovate in ICP OES. Today, Ross and I will discuss some of those new innovations in ICP OES that are coming out of the Spectroscopy Technology Innovation Centre here at Agilent. In 2014, Agilent released the 5100 Synchronous Vertical Dual View ICP OES with dichroic spectral combiner technology. This set a new benchmark in speed of analysis, cost of ownership, performance and ease of use. The dichroic spectral combiner technology combines the light from the axial and radial views of the plasma into one synchronous measurement, allowing measurement of all elements and all wavelengths in a single measurement. This unique technology provides the fastest sample analysis, which creates the lowest gas consumption per sample. The biggest benefit for labs around low gas consumption per sample is that this translates to the lowest cost per analysis and higher profits. The 5100 ICP OES also sets new benchmarks for low power consumption and low exhaust extraction requirements, all of which contribute to the lowest cost per analysis. The 5100 includes a simple to use torch design that's oriented vertically in the torch box. This vertical oriented torch is a very robust configuration. It enables high levels of dissolved solids to be run without excessive torch wear and creates excellent stability for very difficult samples. It's been wonderful to see how our customers in their laboratories have been able to use the DSC technology to solve problems in their analysis. One example is I visited a soap lab not too long ago where they used to run two 6-year-old ICPs. They were able to replace both of those ICPs with the single 5100 SVDV and still get the same productivity that they had previously with the two systems. I also visited a milk analysis lab where previously on a different ICP OES system they were having to do multiple measurements and multiple dilutions on their samples. With the 5100 SVDV, they were able to use a single synchronous measurement to get all of the analytes in a single measurement. The 5100 has added a lot of great value to our customers in improving their workflows and improving the productivity of their laboratories. But Agilent hasn't stopped developing new innovations for ICP OES. We're proud to release the 5110 ICP OES, which includes a lot of those same great features that we talked about from the 5100, but also some great new features that will improve your workflow and the productivity of your laboratory. So Ross, what prompted the release of the 5110?
Feedback from ICP OES operators using high throughput mode for the instrumentation, which is with inclusion of switching valve technology, have indicated that it's complicated to set up and also to use. Additionally, they have indicated that there can be a compromise to the analytical performance from the instrument. The new 5110 with new hardware and software simplifies the workflow and it is dual view minus the compromise.
So Ross, what does dual view minus the compromise mean to our customers?
Some ICP OES instruments can run in a high throughput mode or in a high precision mode, not both. With the 5110, there is no compromise. The 5110 can run high throughput with high precision in the same mode.
Can you tell us a little bit more about the new inclusions to the 5110 ICP OES?
To implement simplicity of operation without compromise, we've added a new fully integrated advanced valving system. Also, we've included enhanced diagnostic software, and we've included a new capability to do rapid qualitative screening as well as semi-quantitative analysis with a tool called IntelliQuant.
So here we are in front of the new 5110 ICP OES. Ross, can you walk us through the setup of the instrument?
Setting up the sample introduction components for a typical aqueous analysis is very simple. We insert the torch, we connect the spray chamber and nebulizer assembly, we clamp the pump tube.
The advanced valve system's located above the peristaltic pump. Can you talk to us about how that simplifies the customer's workflow?
So the new fully integrated advanced valving system is tucked up here out of the way. This is intentionally put in this position so we can completely eliminate physical obstruction with the important sample introduction components. We have easy access to the torch, we have easy access to the spray chamber and nebulizer assembly, and we have easy access to our peristaltic pump tubing. This is the AVS-7. The AVS-7 has a 7-port valve head connected, and the 7th port is for the inclusion of internal standard. It also has a check valve for controlled bubble injection. And we have a high-speed, robust, positive displacement pump. Now, hyphenation of valving systems to ICP OES is not new. Feedback from operators of ICP OES instruments running in high throughput mode have indicated that connection with external valves can be complicated. Also, communication cables through to the auto sampler is tough to connect, and the instrument is very hard to use. The new integrated AVS-7 simplifies the workflow for valve analysis and high throughput analysis.
You mentioned the AVS-7. Are there other varieties of the advanced valve system?
Yes, there is an AVS-6, and the 6 stands for a 6-port valve head. You use the AVS-6 if you're not interested in running internal standard. Now, the 6-port valve head and the 7-port valve head are fully interchangeable, so it makes it very quick to swap between an internal standard method and not having an internal standard. In fact, the interchangeability design is very good also for cleaning and routine maintenance purposes. I'm now going to start the plasma, ready to start an analysis. Another new feature of the 5110 is enhanced diagnostics. We have multiple electronic sensors distributed all throughout the instrument to rapidly give information back to the operator about what's happening inside the instrument. Those sensors feed back information through to actionable error messages, and it also feeds back information to a new graphical interface called the dashboard. So I notice there is an error message on screen with a low airflow. Airflow comes in the fresh air intake, which is right up on the top of the instrument.
Sorry, Ross, I think that's my fault.
Okay, information about airflow also funnels through to the dashboard, so the user can see from a graphical display if there's any problems with airflow or gas supply or chilled water, etc.
Ross, can you talk to us about some of the other automated features in the new diagnostic software?
So in the diagnostic software, we've added in a lot of additional instrument tests. These instrument tests are automated, and the system will go through a self-check. The information you get back will be displayed on screen, a result for the self-check, and also there'll be a pass or fail to that result. Now, the operator can narrow down to a specific module if they do get a fail to help identify where a fault may exist. Access to the instrument dashboard visually informs the user to the status of the instrument around instrument hardware and utility supplies. There are multiple categories of information that can be displayed through the gauge select. Any of these can be graphed for ongoing monitoring. There is even the ability to perform a nebulizer test. Select the type of nebulizer and start the test. Selection of any or all of the instrument tests is up to the user. As the tests progress, values will be displayed and a pass or fail will indicate the outcome of these tests. The results to this system check can be reported if required. How about I show you an ultra-high throughput analysis method? With the AVS fully integrated, a valve method is easily activated through the software. To a new method, activate the valve through the configuration page, add in some elements, accept the default parameters on the conditions page, or further optimise for faster throughput using the AVS 6.7 parameter calculator, insert standards, update the sequence, check auto sampler page is configured correctly, then start the analysis.
Ross, how does a valve method actually increase sample throughput?
The fully integrated AVS 6 we have here, along with the SPS4, contributes to ultra-high sample throughput and exceptional precision. The analysis I'm showing you here today is DTPA extractable cations. Laboratories performing this extraction have hundreds of samples to analyse per day, so they need a very rapid instrumental technique to get through their sample load. Valve methods are able to increase the throughput of sample analysis by being able to perform functions simultaneously. For example, when we use the high-speed positive displacement pump to fill the sample loop, at the same time we are rinsing the spray chamber and the nebulizer. Once the valve switches and the sample injects through to the plasma, we're able to rinse the auto sampler probe and half the valve. In this way, we are performing multiple functions at the same time, and we can dramatically reduce the uptake delay, and we can eliminate the method rinse. The Agilent Advanced Valve System also uses a preemptive rinse. This is where the probe moves to the rinse station prior to the end of the loop fill. This enables rinsing of the probe and valve even before the switch to read the sample. The outcome is excellent washout of the AVS, with 4 order magnitude washout achieved, even with no additional rinse time entered into the method, and highest throughput possible. This analysis is showing a quantitative result every 12 seconds. Even with this incredible throughput, precision achieved for iron over 10 minutes or 50 samples was better than 2% RSD. One of the technologies contributing to this excellent precision is the controlled bubble injection from a pressurised gas line. Bubble injection ensures a long, stable signal and fast sample washout.
Not all customers run thousands of samples per day. Does the advanced valve system also add value for those customers?
The AVS technology, if it's not required for thousands of samples per day, will be ideal for fast turnaround of only a few samples. Not only that, the high throughput technology significantly reduces the wear and tear on common consumable components like the torch and the peristaltic pump tubing.
Ross, some customers have asked for a quick snapshot of all of the elements in their samples. Does the 5110 allow them to do that?
The 5110 has a new function in the software called IntelliQuant. IntelliQuant has the capability for rapid qualitative screening of the sample as well as semi-quantitation. Building up a IntelliQuant method is very simple. IntelliQuant is easy to turn on through the configuration page of ICP Expert software. Activation of IntelliQuant will only add seconds to a typical quantitative worksheet, and for a typical QA/QC laboratory, it provides a lot of additional assurance about what is in the sample. The Elements page allows selection of elements and wavelengths for quantitative analysis, and this is an existing worksheet, so they already exist. Conditions are as per the previous worksheet, so can remain unchanged. On the IntelliQuant setup page, you can choose to use the pre-supplied default calibration for the semi-quantitation, or for higher level of accuracy, you can easily update the included calibration by using Agilent multi-element calibration solutions. Define the standards for quantitation for the 4 elements on the standards page, define your sequence, start the analysis. The analysis that will be activated here is a quantitation of 4 elements and rapid screening of all other elements in the provided IntelliQuant calibration on a CRM sample. Reviewing the results, the recovered elements on the analysis page match the CRM values. Now to rapidly review everything that was in the sample, simply click on the IntelliQuant analysis page. Full spectrum capture is displayed and also semi-quantitative values. Looking at the results, it can be seen that many elements match the CRM values to a high level of accuracy. In fact, the presentation of the semi-quant data into the periodic table heat map makes it very rapid to understand what is present and how much. Dark red is high concentration and yellow is low concentration.
As you've seen today, the new 5110 ICP OES really does simplify workflows in your laboratory, all the way from method development to sample results. The impressive speed of the 5110 ICP OES doesn't come at a compromise in precision. This really does show that the new 5110 ICP OES is dual view ICP OES minus the compromise. New innovations in both hardware and software on the 5110 ICP OES show Agilent's commitment to delivering new and innovative solutions to your spectroscopy problems. For more information on the 5110 ICP OES, including application notes, technical videos, technical notes and brochures, please visit the agilent.com website. Thanks for watching, and we'll see you again soon.